Hello my dear children of class 11 science. Today we do again continue with the chapter that we have started from the last class, that is flow of liquids. So in the last class we had discussed up to the relation. You can see the relation is F, the viscous force acting between the two adjacent layer of the liquid is given by plus minus eta. This is eta, and this eta is actually called coefficient of viscosity of liquid, A, area cross section, and dBx by dz, and this is called velocity gradient. So we are done up to this relation. So from this particular expression of force, okay, we can define and measure the coefficient of viscosity of liquid. The coefficient of viscosity of what? Liquid. And the value of this coefficient of viscosity liquid also determine the nature of the liquid. The nature of what? Liquid. Because all liquid doesn't have same nature. Okay, so what? Same nature. So for this, you can see in the expression of force, there is a what sign? Plus minus sign is there. There is a what sign? Plus minus sign. And this plus minus sign actually indicate that the force between two layers, you can see force between two layers. One force acting this side, another force acting this side. The force between two layers, okay, is mutually interacting force. These two forces are mutually interacting with force. One force acting in towards left, another force acting towards right, and they are equal in magnitude but acting opposite in direction. That's why this negative sign and plus sign actually in the expression indicate on that much only, that the force between the layer is mutual interaction force. Okay. Now the most important thing that we need to do from this relation is we can define the coefficient of viscosity, and we can measure the coefficient of viscosity by the unit. So as you know, for the measurement of any quantity, what you need? Unit. And if a quantity has a unit, that quantity even has a dimension also. So what we do now, we express the unit of coefficient of viscosity and even the dimension of coefficient of viscosity. Now in order to measure coefficient of viscosity and to define coefficient of viscosity, let me make coefficient of viscosity as the subject. So eta, coefficient of viscosity, is equals to now plus minus F whole divided by A delta Bx by delta Z. So this expression measures the coefficient of viscosity. So from here we can even define the coefficient of viscosity. So what I do, I'll take, in the formula I'll take A equals to 1. So I take A equals to 1, and even I'll take delta Bx by delta Z equals to 1. So 1 means what? Unit. So if A, the area cross section of the layer, each layer of the surface is 1 unit area cross section and have unit velocity gradient, this is unit velocity gradient, then substituting the relation, eta equals to plus minus F divided by A is 1, this delta Bx by delta Z is also 1. So now you can see eta equals to plus minus what? F. So coefficient of viscosity of liquid is numerical equals to the force exerted between the two adjacent layers of the liquid, which means from here we can define the coefficient of viscosity of liquid. So as for the definition, as I said, we can even write the definition as the coefficient of viscosity of a liquid is defined as the viscous force. This is the viscous force per unit area. See, per unit area, viscous force per unit area of contact between two layers having a unit velocity gradient between them. So when there is a unit area, okay, per unit area of two layers, okay, in contact with each other and have unit velocity gradient between them, then the coefficient of viscosity of liquid is actually equals to the viscous force per unit area of contact between two layers having a unit velocity gradient between them. That's why eta is numerical equals to plus minus what? F. So this is the expression that from here we define what? Coefficient of viscosity of liquid. Now this definition is true for any of the liquid. Any of the what? Liquid. Now the next thing that we need to do out here is we can express the dimension of coefficient of viscosity. Now we can write the what? Dimension of coefficient of viscosity. So let's come back to the dimension. So dimension of eta. Let me just write eta. Eta means the coefficient of viscosity. So to write the dimension, again I follow the same relation, but I neglect this plus minus sign. So you know what is the relation? Eta equals to F by A delta Bx by what? Delta Z. So this is the coefficient of viscosity. Now the dimension can be written in terms of dimension of force, dimension of area and the dimension of what? Velocity what? Gradient. Dimension of velocity gradient. So I write down the dimension will be, force dimension, you know what is it? ml t minus 2. So you don't remember this dimension? We have learned already in case of dimension analysis. Force dimension is ml t minus 2. Area, what is dimension of area? L square. Okay, into, now dimension of velocity gradient. The dimension of velocity means what? Lt minus 1. And length means L. Length is what? L. So dimension of velocity gradient is velocity, the dimension of velocity, that is Lt minus 1 divided by the dimension of what? Length. Now let's combine it. So I write it down in this manner. So it will be ml t minus 2. This L will go in the numerator, reciprocal, whole divided by, let me combine this in the denominator, L square and L1 only. If you combine, it will be 2 plus 1 means what? 3. L square, L1 means 2 plus 1 is 3. And this is t minus 1. T minus what? 1. Okay. Now we can further simplify this. Now in the numerator there is L and there is also L. Now I combine this also in the numerator. It will be ml, 1 plus 1 is 2, t minus 2. This is in the numerator. Now I'll take this quantity in the denominator. So what happened? The sign of power will change. It will be L minus 3 and T1. Yes. Now let me just combine again. So it will be how much? Only one M. L2 and L minus 3 means it will be L minus 1. T minus 2 and plus 1 means T minus 1. So see what is the final expression that measures the dimension of coefficient viscosity? M L minus 1 T minus 1. Suppose if it asks in the examination to write the dimension of coefficient viscosity, please write it down. M L minus 1 T minus 1. Now after writing the dimension, we can even write the unit also. So we can write the unit from this relation also. And the SI unit of this coefficient viscosity can be written from here only. M implies mass. The dimension SI unit of mass is what? Kg. L implies length. The SI unit of length is what? Meter per meter. T implies time. The SI unit of time is second per second. So you can write from this dimension also. So what is the SI unit of coefficient viscosity? Kg per meter per second. Okay, kg per meter per second. But this kg per meter per second can express by the unit called poise. So I am writing out here, that is expressed in terms of what? Poise. And 1 poise, I am writing out here 1 P-O-I-S-E, poise. The unit of coefficient viscosity is also equivalent to 1 by 10 kg meter per second. So look at it. SI unit of coefficient viscosity is kg per meter per second, but this is also equivalent to the poise. But as for the relation between poise and kg per meter per second, so 1 poise is equals to 1 by 10 kg per meter per second. So if you cross multiply, you can even write as 1 kg per meter per second is equivalent to 10 into 1 means 10. And this is 10 poise. How much poise? 20 poise. So 1 kg per meter per second is equivalent to 10 poise. Okay, equals to how much poise? 10 poise. So poise is also the unit that can be expressed for measuring the coefficient viscosity. But we can look at the relation. 1 kg per meter per second is equivalent to 10 poise. Now children, we go to the next topic, that is factors affecting the coefficient of viscosity of liquids. Now coefficient viscosity of a given liquid is not constant. It will change. That means this factor, liquid will basically change due to some of the factors. So one of the factors that affect the coefficient viscosity of liquid is the temperature. So temperature will change the coefficient viscosity of liquid. That means the first factor I write down is the effect of what? Temperature. Effect of what? Temperature. But to know what way the temperature affect the coefficient of viscosity is basically for all the liquid, the viscosity of liquid decreases. It will what? Decreases sharply with the increase on temperature or rise in temperature. Means when temperature rises, the viscosity of liquid decreases. That means the liquid experiences less viscous force, so that the flow of liquid can increase. Okay, but this viscosity can even become zero at what temperature? Boiling temperature. Like water, boiling temperature is what? 100 degrees Celsius. The viscosity of water becomes zero at 100 degrees Celsius. Okay. Similarly, other liquid also viscosity becomes 0 when the temperature reaches to 100 boiling point or reaches to boiling temperature. Now this is the case of liquid. But if I take a gas, because gas can also flow, so gas viscosity increases with increase in temperature. So this is just a note, you can write it down. For gas, the viscosity of liquid increases with the increase in temperature. That's why, as I said, like for gases, okay, the viscosity of viscosity of gases, this is viscosity of gases increases with increase in what? Temperature. Now this is one of the factor that affect the viscosity of liquid. The next factor that also affect the viscosity of liquid is the pressure. So I write down effect of pressure. So to know by what way the pressure affect the viscosity of liquid is basically with increase in pressure, the viscosity of liquids, means almost all the liquid except water, generally increases. When the pressure increases, viscosity of all the liquid increases except water, because water, in case of water, okay, when the pressure increases, viscosity of liquid decreases, because water shows a different behavior, that is called anomalous expansion of water takes place as compared to the other liquid. That's why in case of viscosity also, when the pressure increases, viscosity of water decreases. But other than water, all the liquid viscosity increases with the increase in what? Pressure. So this is the effect of pressure. Similarly, if you go through the gas, if you take gas as a fluid which can also flow, the viscosity of gases is almost independent of the change in pressure. Means whether pressure increases or pressure decreases, but viscosity of gas almost remain constant. So next, the last factor that we can see for the effect of viscosity of liquid is the effect of density. Means density of liquid also changes the what? Viscosity of liquid. That's why you know that different liquid has different viscosity because of different density. Now basically, if you go through the liquid having different density, the viscosity of liquid increases with the increase in density. That's why if you go through the different liquid, then different liquid have different density, but any liquid which has more density, more viscosity. Okay, that's why one is honey. You take one is honey, another is water. So viscosity of honey is more than viscosity of what? Water. Because honey is more denser than water. Okay, similarly we can compare with other liquids also. But remember this first, when a liquid which has more density, that liquid has more viscosity. Okay, that's why viscosity is directly proportional to the density of the liquid. But if I take in case of gas, it is just opposite. That means the viscosity of gases, okay, decreases with increase in what? Density. Decreases with increase in what? Density. But out here you don't have to discuss in details of why it decreases and all. So we are actually concentrate only with the liquids. That's why the chapter is completely based on the flow of liquids. So children, I have explained in detail about even the factors affecting the coefficient of viscosity of liquids. Now we go to the next topic, important topic that you learn in the next YouTube video, that is the principle of continuity. Okay, and that you learn in the next YouTube video.